Hello and welcome to today's webinar brought to you by Copeland. My name is Shweta Singh, Marketing Business Partner of Copeland, and I will be your moderator for today. We are excited to have you join us for this discussion on transforming sanitary water heating in residential space and Copeland heating solution for home, villas, and bungalows. So what we will explore today is the working principle of heat pumps for sanitary water heating, how sanitary water heating stack up against conventional heating technologies, and how Copeland leading the way in sustainable, efficient, and future-ready residential water heating solution. So before we get started, here are a few housekeeping announcements. This webinar audio is available through your computer sound system or by phone. So ensure your settings are adjusted for the best experience. Feel free to submit your question at any time during the webinar using Q&A panel on your screen. We will address them during the Q&A segment and follow up on unanswered question via email. So to guide us today to today's discussion, we are pleased to welcome Rahul Pathak, Head of Marketing and Product Management at Copeland. Rahul brings a deep expertise in sustainable HVACR solution with a strong focus on energy-efficient technologies like heat pumps. He has been instrumental in driving Copeland's heat pump and air conditioning portfolio in India, developing strategies, launching innovative products, and positioning them to meet the evolving needs of the market. His insight today will help us better understand how heat pumps are transforming sanitary water heating in modern living environment. Without further delay, I will hand over to Rahul Pathak to begin the presentation. Thank you all for being here today.
All right, so I can see people are joining in. I'm sure the number will go on as we move forward. So thanks for joining today's session on the Copeland heat pump for the residential segment. Of course, we'll have discussion on both residential and commercial, but more focus would be on the residential segment installation on the heat pump. All right, so I'll go to the first chart, and the way we have structured today's discussion is we will talk about a little bit about what Copeland is all about, what we do, and then followed by the core discussion on the heat pump, where we will discuss about the working principle of heat pump, how it is installed, why we call heat pump as a green technology compared to other conventional way of heating, followed by types of heat pumps. Then we will have few inputs on how do we select the heat pump for your installation requirement. So we'll go through those details. More importantly, we will also have discussion around what things end customers should check before selecting a heat pump. Very, very important for any end customer, any influencer like architect or a consultant in the project selection, right? So we'll have more discussion on what things one should check before finalizing the heat pump make. A few case studies, couple of case studies, just to kind of show you how heat pump is a better solution for an end customer compared to conventional way of heating. Few installation sites, we will share those installation sites with you, some photographs, just to kind of get a hang of how the heat pump installation is done. And then finally, we'll share the contacts of our Copeland colleagues so that you can get engaged with Copeland for further inputs on the heat pump, and if you have any inquiries, any requirement of the heat pump, you can directly get in touch with the Copeland colleagues and take it along. Yeah. With this, let me start with the introduction of Copeland. So we are actually a 100-year-old company, started way back in 1921 by Mr. Edmund Copeland. He was the one who started this company for a refrigeration application. And then in 1986, Emerson Electric bought this company from Copeland. It was a company under Emerson brand from 1986 till 2023, almost for 36, 37 years. And then in 2023, it again became a standalone company owned by a private equity company called Blackstone. They are based in New York. And with this integration with the Blackstone, there has been a lot of focus on the overall investment and the focus on the overall customer engagement on the HVACR side. So it's been 2 years that we are now part of the Blackstone Group as a standalone company serving our HVACR industry. Right now, I'll move to the next chart. There's a delay of a couple of seconds, so please bear with us. So we are a global leader in the sustainable heating, cooling, cold chain, and industrial solutions for commercial, industrial, cold chain, and residential market. And we serve this market and the end customers and help them to kind of use better refrigerant or a greener refrigerant. We help them to achieve the energy efficiency norms. We help them to achieve the safeguarding their food. So if you name any industry here, whether it's commercial, cold chain, industrial, residential, we are there with our product and solution. So, Copeland actually, operates with around 18,000 plus employees over 40 plus countries. We have a strong presence as far as the global operation is concerned. We have 3,400 plus active and pending patents, and we did that with the help of around 2,300 engineers across the globe. And we are, in terms of the revenue, we are like $4.7 billion company. And interestingly, 80% of this revenue comes from the repair and replacement cycle. Thanks for a 200 million plus global installed base all across globe. And when I say 200 million plus, it consists of all the products that Copeland sell to the market, right from the compressor to the condensing unit to the heat pump to the electronics. If you consider all the product breadth we have under Copeland, the 200 million plus consists of all that product range. And we being the global company, it's our privilege to kind of serve this global market of HVACR. Move to the next chart. As far as the Copeland India is concerned, we are headquartered in Pune. So we have corporate office in Pune. At the same time, we have a global engineering center in Pune where around 350 engineers sit in Pune and help our manufacturing sets set up across globe. So most of the engineering related work is done at Pune Engineering Center. Then we do have a engineering center dedicated for our manufacturing plant in Atit, very close to Pune, around 100 kilometers towards Bangalore. And so we do have around 30 plus engineers who helps us to design those products, as well as we also have the Enable accredited psychrometric lab. And then we also have the TDA capability for a scroll compressor, and as well as a training center over there. We talked about the manufacturing presence where we manufacture the compressors as well as the condensing unit and the heat pump for India market. We have a cold chain center. We'll not talk much about it because today's forum is different. And we do have a very strong channel network, whether it is a compressor business or a heat pump business. As far as heat pump is concerned, we do have around 30 plus system integrators who have been appointed all across India. So with this uh, background on the Copeland and the Copeland presence in India, we will switch to the second topic, which is the heat pump topic. Now, what we will do is we'll quickly go through the history of water heating technology. Right now, today, if you see, this water heating technology has been evolved uh, and traveled a lot of distance from last 100 years, I would say. All it started with, wood-fired heating, and then it slowly turned to the uh, electrical heaters and geysers, then followed by the LPG-fired heaters, and then recent times, market has started using the solar water heaters also, and now, most of the installations or the upcoming installations are being done with the heat pump technology. So this is how the evolution of the water heating technology has been done from last many years. If you try to compare all these technologies in terms of 5 to 6 parameters, whether it is the energy saving, space requirement, the operation, which is climate independent, the maintenance, the safety, the environmental friendliness. If you take into consideration all these parameters and try to compare these parameters, or try to compare these technologies based on these 5 or 6 parameters, there are pluses and minuses for each of the options which you see on the screen, right? And the way we have designed this chart is the one which you see in the red. That means it's not a good sign against that particular parameter. If you see a green sail, that means it is supportive to that parameter. And based on that, you can see at the bottom the overall score out of 7, right? So if you take into consideration the wood-fired heating, you can see around 2 greens for space requirement and efficiency. Space requirement and the maintenance, and rest all parameters are red. That means the overall score is 2 out of 7. If you switch to the electrical heaters and geyser from wood-fired heating, you get a extra benefit of climate independent operation because if you have electricity, you can easily use that. So that becomes green, and the safety has been added compared to the wood-fired. So 4 out of 7 is the score for electrical heaters. Then comes LPG-fired heaters. Now the score has dropped by 1. The reason is the safety, because though LPG is kind of convenient for people when there is no electricity, and if you want to attend an office, LPG-fired heaters are convenient to use, but at the same time, if you don't have a sufficient ventilation, then it might become a problematic area. So safety is something which is kind of a concern as far as LPG-fired heaters are concerned. So the overall score for LPG-fired heater is 3 out of 7. And then the fourth option is the solar water heaters, where the score is 5. Most of the parameters are green, except 2, which is space requirement, because you do need a lot of space to install this, solar water heaters. And the climate independent operation is always a question mark, particularly in the rainy season for solar water heaters. So that becomes red, right? So 5 out of 7, good score, but still we have couple of challenges in terms of the climate independency and the space requirement, which you see on the heat pump is 6 out of 7, the highest score among all the options. That space requirement continues to be a problem because you do need an installation of a heat pump along with the mixing water tank. We do need some space at the terrace level, but barring that, whether it is the energy efficiency, climate independent operation, maintenance, environment friendliness, safety, all are green, right? So that's the reason today, whether it is government, whether it is energy efficiency bodies, whether it is corporates like us, whether it is consultant, whether it is the key stakeholders in the industry. Everybody is talking about the the advantages of the heat pump and why one should use a heat pump compared to other technologies, right? And the last but not the least is the boxes which you see in each of the technologies with a COP number, right? So we'll talk about what is COP and the significance of this COP in these technologies later. But COP of a heat pump, you can see it's around 3.5 to 4, the highest one, which is a good thing for a customer compared to the COP of other technologies, which is hovering around 0.8 and 0.9. Now, what is 0.8, 0.9? What is 3.5 or 3.5 or 4? How does it help end customer? It's something which we'll talk in detail in the next chart. Yeah. All right. It's taking a time, but yeah. All right. So let's see how the heat pump works. So you can see here on the left-hand side, the schematic of a heat pump. When you open a box of a heat pump and see what component goes into it, this is what you will see. You will see a compressor. You will see two heat exchangers. One is evaporator and one is condenser. You will see small components like thermal expansion valve over there, but predominantly, these are the 3-4 components which you will see when you try to open a heat pump. Okay. Now, in a simple language, let me put it the working principle of a heat pump so that everybody knows about it. The job of a heat pump is to absorb the heat which is available in the atmosphere and transfer that heat from that point to the point where we need hot water, right? So you can see here the evaporator is absorbing the heat from an ambient which is available, and this evaporator is nothing but, I don't know if you are able to see this clearly, but this portion is your evaporator, and this is where you start absorbing the heat from the ambient, right? And then it's passed to the water to be heated through a condenser. Now, condenser is seated inside the heat pump, so you won't be able to see it here. But if you open it, you will see the condenser. Of course, there are different types of condenser, but the point I'm trying to make here is the heat which is absorbed here through evaporator is passed to the water to be heated through condenser. And then you will see a connection between a storage tank. So this is where you store the hot water. You can see on the actual image also, and those are connected to the condenser pipes here, right? And there is a continuous flow from storage tank to the condenser and back to the storage tank, right? And this is how you continue to get the hot water as per your requirement, whether it is 45 or 50 as per your setting, right? Now, all this happens, the medium is the refrigerant, right? So you can use a 407C refrigerant, 134 a refrigerant, 410 a refrigerant, right? But most of the time, these are the refrigerant you will see in a heat pump. And this is the medium through which the heat is extracted at one point and it is given to the water at a different point, right? Now, in the overall process, as I said earlier, the COP is very important as far as the operation is concerned. Now, if you see on the bottom side, you will see the COP values of different technologies, whether it is electrical heating or a combustion type or a heat pump. The heat pump has the highest COP, which is 3.5 to 4. Now, COP is nothing but the coefficient of performance. Now, being an engineer, I'll say, it's output of a heat pump in a kilowatt upon input power, which is a consumed input power by a system in a kilowatt. Now, it's very easy to say, but in a simple language, I'll put it in a different way. So what it denotes is, if you give a 1 kilowatt of input power, you will get 3.5 to 4 kilowatt of output power in a heat pump, right? So it's nothing but 3.5 divided by 1. That means your COP is 3.5 to 4. Yeah. So it multifolds, right? So if you are giving a one input power, 1 kilowatt of input power, it multifolds to 3.5 to 4 kilowatt as the output of a heat pump, right? Which you won't see in a technology like electrical heating and combustion heating. You will see if you give a input power, 1 kilowatt of input power, you get zero point 0.9 or zero point 0.8 kilowatt as the output because of the losses. And that's where there is a lot of difference between the conventional way of heating and the heat pump in terms of the efficiency because of the COP level. Now, one will definitely ask why. There's always a why to all the facts, right? So definitely people will ask why the COP of heat pump is 3.5 to 4 and why electrical or combustion time do not have a COP of 4, right? So the answer is on the top hand side, if you see, out of the overall 100% heating capacity, the 75% of the heat which gets generated is extracted from the ambient itself, right? So if you see here, the evaporator which absorbs the heat is overall 75% of the heat which is available at this side where we get the heated water. That 75% of the heat is recovered or is fetched from the ambient itself. Only the 25% of this active power is consumed by compressor, evaporator, and the circulation pump power, right? Which is the active electricity that you will need to kind of operate this heat pump. So that's the reason it is a 75 and 25% principle. 75% freely available, 25% is something which you need from the power grid. That's the reason the COP of a heat pump is 3.5 times to 4 times compared to the conventional way of heating, right? So very, very important chart. If somebody wants to know why heat pump is considered as a greener technology, so this is the answer. Now, obviously, what I talked today on the COP is at a standard rating condition when the ambient is 35 degrees Celsius with a water in and water out delta of 30 degrees Celsius, right from 20 to 50 degrees Celsius with a RH of 60%. But imagine when the ambient falls down from 35 to 25, 25 to 15, 15 to 5, 5 to 0, right? So obviously, as the ambient goes down, it becomes more and more harder for a compressor to fetch the available heat from the ambient, right? So obviously, you won't get the COP of 3.5 to 4 when the ambient goes down, but it will definitely be higher compared to the electrical heating or a combustion heating. So even if the ambient is, say, for example, 5 or 4 or 0, the COP would still be around 1.9 to 2.1 kind of a range. Okay, but it will be definitely be higher compared to the conventional way of heating, right? So with this background, the basics of the working principle of a heat pump, I will go to the next chart, which talks about the types of the heat pump. Now, obviously, there are a lot of types you will see in the market, but predominantly you will see the commercial and residential heat pump, commercial heat pump, industrial heat pump, and the swimming pool heat pump, based on the end application, based on the temperature which needs at the end use. So this classification of heat pump is done, right? Now, obviously, since today's session is on the residential, I've highlighted that into a yellow color. So residential heat pump is a heat pump which delivers you 55 to 60 degrees Celsius water output temperature. And again, it is further classified as a split water, split refrigerant, and a monoblock systems. And all of them are air to water. That means, the heat is absorbed from the atmosphere through a air mode and it delivered to water, right, at a condenser. That's the reason it is called as an air to water heat pump. And obviously, there are further classification of split water and the split refrigerant. Won't go into those details, not needed. But one obvious point is, what is monoblock? Monoblock is kind of a very similar technology. The only thing is that In split, the water tank and the actual heat pumps are separated, whereas in monoblock, uh, whether it is a the HVAC system or the heat pump and the water tank, both of these are integrated and sold as one box to the end customer. Of course, there are few disadvantages of using a monoblock, particularly on the availability of a local locally manufactured monoblock and complexity of the overall design. So, in a simple language, today's scenario, it would be safer to use a split system of a heat pump for a residential rather than going for a monoblock system for a residential project. Yeah. All right. So we'll go to the next chart, which talks about, and these residential heat pumps are used in bungalows, villas, where you have large apartments like 4-bedroom, 5-bedroom apartments, right? So you can use these residential heat pumps. Now, it's important to have you know, uh, a right combination of a heat pump and the mixing water tank, right? For example, if you're trying to use 100 lph, that means a liter per hour, the heat pumps are categorized based on the kilowatt of a capacity or a lph capacity. So lph or kilowatt, both the units are referred by the industry players. Lph is nothing but the liter per hour. That means if you are talking about 100 lph, that means you get the required heated water uh, uh, in 1 hour for 100 liters. So you get 100 liter of the required heated water in 1 hour. So that is 100 lph. If you like combine this with a 300-liter water tank, that means you need 3 hours to get the entire 300-liter of water tank to be heated. If so, that's a fast heating, but the same heat pump, if you combine with a 500-liter, that means you need a 5 hours to get the heated water of 500-liter, right? So it's all about how do you combine heat pump and a mixing tank based on your requirement. And for that, our experts are there. The system integrator that we have appointed all across India, all of them are very, very familiar with what combination of heat pump and mixing tank should be given to the end customer based on the requirement and the site condition. Yeah. So that's on the selection of the heat pump and the selection of a mixing tank for your project. I'll go to the next chart, which talks about the things one should check before selecting a heat pump for your project, right? Now, the 2-3 charts which I'm going to talk about, of course, is talks about the heat pump for a commercial project installation, but there is one chart which also talks about the thing that which one should check for a residential heat pump project also, right? Uh, the reason why I have included commercial is because there are many times that there are projects which are neither in residential category or commercial residential category or a commercial project category. It's in between, right? We call it as a light commercial. Like for example, you have 20 or 25 rooms hotel where you end up selling a residential heat pump because the heated water requirement is on a lower side. So though on a definition side it is a commercial project, but we end up selling a residential heat pump for that. So that's the reason I have included a couple of charts which are the things to be checked even for the commercial projects, right? Okay, the first thing is the compressor which is used in a commercial application or a commercial heat pump. Now you should always demand for a ZW compressor, which is a specialized compressor needed for a heat pump requirement for a commercial. Now this ZW is different compared to a standard scroll compressor because you need to be as a compressor you need to be very sure about the overall operation, because it's not a normal air conditioning system, right? For example, if you see here on the top hand side, if you want to maintain 20 degrees Celsius inside a home when the outside is minus 7 degrees Celsius, it is relatively easy for a system to maintain a 20 degrees Celsius when the outside is minus 7, because the work done by a system is relatively easy, because minus 7 you have to kind of achieve a condensing temperature of 40, because here in a technical language, to maintain a 20 degrees Celsius, the coil difference should be around 20 degrees Celsius, right? So condensing temperature has to be 40 degrees Celsius. Whereas in a sanitary heat pump, if you need a 50 degrees Celsius water, that means your condensing temperature has to be 55 degrees Celsius. That's how the sanitary heat pumps are designed. So imagine when the outdoor, temperature is minus 7, it's minus 12 here, but even if it is minus 7 to 55 and minus 7 to 40, there is a difference, right? So there is a lot of work a compressor need to do in a sanitary heat pump compared to a space heater air conditioner which you use, right? So the point here is, if you try to use a compressor which is used in a standard air conditioner in a heat pump, the probability of uh, you know failure of that compressor in a heat pump is high, because of this worse or a high, uh, challenging operating condition, right? So always ask for whether the heat pump is installed with a dedicated heat pump compressor, which is a ZW scroll compressor. Very, very important for any end customer, right? Then second point that one should check is the of course the same thing, the operating envelope is we'll not go into the details because it's too technical for this audience, but if you see here, this operating envelope, nothing but this is a safe zone for any compressor to operate. If you go beyond those boundary limits, then you are asking compressor to work under danger zone, right? So if you see the envelope of a ZW or dedicated scroll compressor here for a heat pump, you can see it goes as high as 69 to 70 degrees Celsius. So very, very comfortable, delivering a 60 degrees Celsius hot water here, right? So it is designed in that way so that it can deliver the required hot water temperature for your use, right? Then moving on to the next chart, which is related to the Green Pro certification. Of course, this is again related to the commercial projects, because most of the projects, of course, there are residential projects with the green, but most of today's projects, the IGBC green buildings are for the commercial range. So what we thought was we will certify our heat pumps for a commercial range with a Green Pro certification. So we did that. We worked with the CII IGBC team and qualified ourselves for a commercial range with the IGBC Green Pro certification. So before that, so what they do is they check all the things from a heat pump manufacturer, right from the raw material which we use, the manufacturing process, the product performance, and the end of life management. All those parameters are checked, and it is checked every 2 years. We have to recertify our products every 2 years, not that once we get it, it is valid for lifelong. No, every 2 years we get the recertification from IGBC for a Green Pro certification, and it helps particularly on the IGBC rated buildings. So if you see on the right hand side, there are 4 categories, as you know, as far as IGBC rated buildings are concerned. It starts with certified and goes up to platinum, and based on the overall score, the certification is done. So what these Green Pro certified heat pump helps is it gives an opportunity for an end customer or a consultant or architect to kind of score a couple of additional points, because there are reservations in the scoring table which they have given for usage of a Green Pro certified product. So we'll not go into the details, but the point I'm trying to put here is, if you use a Green Pro certified product or a heat pump, there are high chances that you get a couple of additional points in the overall scorecard. Yeah. So very important as far as asking a Green Pro certified heat pump. And it's just not Green Pro certification, but it's just a mark of guarantee that whatever we are declaring on a catalog, you will get those efficiency level at a ground level, right? Moving to the residential heat pump, again, very important when you select a heat pump, what things you should check before selecting a heat pump for your residential project. Very first and important point is the of course few points related to the silent operation, because today's your bungalows and or villas are so close to each other that the silent operation of a heat pump becomes very important. Otherwise, your neighbor will start complaining about your system, right? So always look for a silently operated heat pump, and then always ask for a condenser which is called as a VSIT, which is nothing but vertical spiral inside tube condenser. State of the art, very latest technology as far as the condenser is concerned for a heat pump application. What it does is it minimizes the heat exchange losses between the refrigerant and water. If you remember what I talked in the earlier chart, this is where the heat exchange takes place between the refrigerant and water. This is where the the heat is exchanged through refrigerant to water, right? And this is done through a condenser. So if you use a condenser where the heat losses are minimized, you will get the maximum benefit out of the overall operation of the heat pump. So always ask for a VSIT condenser over there. Second is the operational performance, because a lot of time, you end up using a heat pump in a very low ambient condition, as low as -5, right? So it's very important for end customer, because when the ambient goes down, that's where you need a heat pump. You don't need a heat pump at a summer condition of 45, 50. You will automatically get a heated water. The end customer will need a heat pump when the ambient goes 15, 25, 0, right? And if your heat pump don't deliver at those low ambient condition, then it doesn't make any sense for end customer to use a heat pump, right? So always ask for a heat pump where the operating point goes as low as -5, right? And then is the four-way valve. Ask whether the heat pump is equipped with a four-way valve or not, because what it does, I don't know if you see this four-way valve, the picture on the right-hand side. These are the four valves, and you have a cylinder in the center, and it is equipped again with the solenoid valve. The top portion is connected to the discharge side of the compressor. The middle one is connected to the suction of the compressor. The left-hand side is connected to the evaporator, and the right-hand side is connected to the condenser side, right? So in a normal condition, uh, the discharge is connected to your condenser and the condenser and the evaporator is connected to each other. But when the ambient goes down, like for example 0 degrees Celsius, slowly the icing starts forming on the evaporator, and then it becomes difficult for heat pump to kind of extract the heat from the ambient itself, right? And your operation of the heat pump will be under critical criteria or critical area. So with the help of a four-way valve, what we do is we reverse the flow of the refrigerant, right? And then once the moment you reverse the flow of the refrigerant, your discharge is connected to the evaporator, right? And then your ice start melting, which is formed on the evaporator coiling, right? So that is how you get rid of the ice formed on the evaporator in a winter condition, harsh winter condition, and get rid of that icing formation on the evaporator. We call it as a latest technology of a defrosting in a heat pump, which is very, very critical. People use electrical auxiliary coils, but those are energy guzzlers. We are talking about a energy efficient systems, heat pump systems. If you try to make a hybrid system by introducing a heating coil, there is no point calling it as a greener way of heating the water because you are using a electrical auxiliary oil coils over there, right? So please do not go for any heat pump which has electrical coils on the evaporators, right? Then third is being architects, always go for a sleek and compact design. You can see ours is a 2.7 square foot area footprint with a less than 2 feet height, right? And uh, and the last one and the important thing is the controller itself. Okay, so these are some of the points that one should always look at while before you select a heat pump for a residential project. Then we will go to the next chart, which talks about the range. So as far as Copeland is concerned, our range starts from 3.5 kilowatt and goes up to 7 kilowatt for residential. We have launched the next generation of our own 7 kilowatt recently, and we are in the process of launching 5.2 kilowatt next generation in September 2025. And for commercial, it goes from 11 kilowatt to 72 kilowatt. That's the range. And for pool heating, the range is from 13 to 86 kilowatt. That's all. Heat pumps are designed for 55 to 60 degrees Celsius. We do have one product which gives 70 degrees Celsius heated water, because there are few projects where you need a 70 degrees Celsius water heat pump, water temperature at a 5-star hotel where they want to prevent the bacterial growth in the water pipe. So for those niche application, we have designed it so it's available as far as Copeland heat pump is concerned. So there are obviously few advantages of using a Copeland. We'll not go into the details, but most of the point that we have discussed so far are summarized here. So you'll get a copy of it. I'll just skip it. So now we will talk about the couple of case studies, the actual case studies. First case study, you will see a hotel in Krishna in Maharashtra, a 25-room, a hotel very close to the requirement of any large bungalows or large villa, right? Of course, it may not be. So because we ended up selling a 200 LPH heat pump over here, which is categorized as a residential heat pump. So this project was using boilers earlier, and there are a lot of operational challenge you will see at the bottom, whether the availability of the wood or difficulty catching fire in the monsoon area. Then people had to kind of the employees of the hotel has to kind of switch on the boilers every night at 12 o'clock so that by 5 a.m. in the morning people can get the heated water at their bathroom. If they miss, then there are a lot of problems, because if they miss firing the boiler at 12 midnight, then people used to complain at 5 a.m. in the morning that there are no heated water available in the bathroom, so far and so forth, right? So that project owner or the hotel owner was really frustrated with the boiler operation, and then he approached Copeland and we replaced boiler with a heat pump. And you can see on the right hand side, the running cost of the boiler here was around 1,82,000 rupees, which we brought it down to 1,10,000 rupees with the heat pump, right? So in 2 years, he got the incremental spend which he did for buying a heat pump compared to a boiler. And after 2 years, every year, and he's saving around 70 to 80,000 rupees in a year, right? So that's how heat pump makes life easy for you. That's how heat pump saves your running money compared to the conventional way of heating. One more example, quick one, which we have used in a swimming pool application, where inline heater for 43 kilowatt, the running cost was around 8,47,000, which got brought down to 1,16,000 of a heat pump. Of course, the initial cost jumped from 50,000 to 15 lakh rupees for a heat pump, but all that got recovered in just 2 years, because the saving per year was around 7,31,000. Okay. Now we'll go to the next point, some heat pump installations, right? A quick one, just few photos. You can see hotel in Varanasi, some Sikkim, right? You can see the how the heat pumps are installed, how the heat pump looks, how it is integrated with the water tank, how the water tank looks. Most of the installations are at a terrace place. So you can see the Shillong, right? Most of them are challenging sites where the ambient went down to below 0 degrees Celsius. Just for your information, how the installation is done. And most of the leading hotel chain, Copeland heat pumps are preferred, right? So with that, the key takeaways of today's session is heat pump is one of the greenest technology option available today for as far as the sanitary water heating is concerned. Checklist for residential project is silent operation has to be less than 63 dBA or at least 63 dBA. Always ask for a VSIT condenser, which is available inside the heat pump. Inbuilt water circulation pump is very, very important for a residential projects. May not be as important as commercial, because commercial the dynamics are different, but for residential projects the requirements are kind of similar. So you have to have an inbuilt water circulation pump for residential heat pumps. That means 100, 150, and 200 LPH heat pumps are called as a residential heat pumps. Four-way valve we talked about, very important as far as the low ambient operation of a heat pump is concerned, and the sleek design of heat pumps, right? And made in India. So these are the 5-6 points for a residential projects. And for a commercial projects, the made in India is of course there, but Green Pro certification, GW dedicated compressor, shell and to condenser, because which is nothing but a condenser where you can service, you can, if the water quality is not good, then there is a high possibility of putting, accumulating the scaling inside the condenser, which might hamper the overall operation of the heat pump. So, but if you prefer a shell and tube condenser, then it is serviceable. You can remove those scales. One should not use the auxiliary coil in any heat pump, whether it's residential or commercial projects. So, stay away from using a heat pump where the auxiliary coils are used, and a four-way valve, even for a commercial projects, makes a lot of difference. So this is our contact, Rohit Kulkarni, who is a business head for heating solution. He is present today. His email ID is rohit.kulkarni@copeland.com, and his mobile number is 9272100897. If you have any inquiries, if you need any further information, want to connect with us for more details, please get in touch with him, and we'll be happy to serve you further. Yeah, with this, thank you so much for attending today's session. I'll hand it over to our moderator, Shweta.
Wonderful. Thank you, Rahul, for the insightful presentation. And I'm sure that the audience has gained valuable insight into Copeland efficient wide range of heating solution. Now, as we have some time left, we'll take a few of our questions from the audience. And if we are unable to address all your questions due to time constraint, rest assured we will follow up and respond the remaining questions through emails. Okay, so I'll quickly go to this question. So the first question is, why heat pump have higher COP than conventional heating?
Okay, I think we included that in first couple of slides. The reason is the 75% of the heat needed is absorbed from the atmosphere itself, and only the 25% of the heat needed is fetched from the active power to run your compressor and the inbuilt circulation pump. So that's the reason the COP of a heat pump is in the range of 3.5 to 4, whereas the conventional heaters have a COP of 0.8 to 0.9 because of the electrical losses which you see in the coils. So that's the reason the heat pump has a higher COP compared to the other ways of heating the water.
Okay. Thank you, Rahul. So the next question is what is the significance of four-way valve in heat pump?
Yeah, I think again, it's a bit technical, but I tried to kind of simplified it while I explained the function of a four-way valve. So the four-way valve, the operation of the function of a four-way valve is to reverse the flow of the refrigerant, right? So what it does is the discharge line of the compressor is connected to evaporator instead of connecting it to the condenser, so that the high temperature refrigerant goes inside the evaporator coil, and the ice which is formed at a low ambient temperature is melted, and the heat exchange again start happening. So the job of a four-way valve is to remove the icing in a winter ambient condition, which it does. And it's the smoothest way, efficient way of a defrost mechanism compared to an auxiliary coil. So please do not go for an auxiliary coil defrost for a winter condition, as it is an energy guzzler for any end user.
Okay. Okay, great. Now we have one more question. It is interesting. So, is Green Pro certification compulsory for heat pumps?
Well, it's not a compulsory certification for any end customer, but it is always advisable to go for a Green Pro certified heat pump. And the reason behind is it is nothing but a mark of a guarantee. Two reasons. One is it is a mark of a guarantee that the heat pump which you are purchasing will deliver the promises from the catalog. So if you are saying my heat pump has a COP of 3.8, it will deliver 3.8 at the site. Okay, there won't be any deviation as far as what we declare compared to what end user will get at the project site. That's point one. The second is, if you are pursuing for a certification for your commercial building for a IGBC, the Green Pro certified heat pump will help you gain a couple of additional points, right? So these are the two reasons why end customers should always ask for a Green Pro certified heat pump for a commercial projects.
Okay. Thanks, Rahul. So we'll take one more question.
Okay.
So the last one maybe. So what are the steps to finalize heat pump model, and how we can order directly from Copeland?
The heat pump selection is a little tricky, and that's the reason I said we are very choosy while finalizing our system integrators. All of our system integrators are so well equipped and experienced that before they start serving a heat pump for a particular project, they take some critical input from end customers in terms of the water consumption pattern, the site location of the project, right? The timings of the water consumption. So all those inputs are considered, and then based on that, the heat pump size and the water tank size is finalized, and then they start further discussion with the customer. But as I said earlier, if you make a mistake in terms of the selection of the heat pump and the selection of the mixing water tank, it becomes harder and harder for end customer to kind of cope up with their requirement later on. So always go for right selection, where the Copeland system integrators will definitely play a major role to help you out. That's point one. And second is, our system integrators are appointed all across India, all major cities. And if you have any questions, please reach out to Rohit, and he will help you out to kind of contact to the right system integrator for your project.
Great, Rahul. Thank you so much. So now for the rest of the question, we'll get back to you through emailers. We'll answer all your queries. Okay.
Great.
So you can see a scanner now. So you can scan our QR code and you can download the latest Copeland heating catalogs and materials. And you can also follow us on our Copeland social media pages to stay updated with Copeland solutions. So that concludes today's webinar. Thank you so much for joining us and taking the time to explore Copeland transforming sanitary water and commercial heating solution. We hope the insights shared today help guide your efforts in adopting energy efficient heating solutions for residential commercial spaces. And for any question, if we couldn't answer today, we will answer through emails, as I said. And just as a reminder, a recording of this webinar will be available on demand. So thank you for your time and for responses. So on behalf of everyone here at Copeland, thank you for attending this session. We look forward to connecting with you in our future sessions. Thank you. Take care and have a great day.